3.4 introduces angle addition postulate. Angle addition postulate is almost identical to the segment addition postulate in what it stands for, and that is that the whole is equal to the sum of the parts. Okay? And a reinterpretation of that is that an individual part is equal to the whole minus the other part. So that not only works for segments, but we now see with this postulate, which again is not going to be proven, it's just going to be assumed to be true and is accepted as such. But it says that these two relationships are true for angles as well as segments. Okay, so the three variations of how to interpret angle addition postulate is the whole, angle ABD, is equal to the sum of the parts, angle ABC, and angle CBD. Okay. And then also the individual pieces. So an individual part, such as angle ABC, is equal to the whole angle, ABD, minus the other part, CBD. And then the last way that you can interpret this is for the lower part here, angle CBD is equal to the whole thing, ABD minus the other part, ABC. Okay, so all of these can be justified by the same reason, and that reason is angle addition. Okay, that's the abbreviation if you're writing it out by hand. If you're typing it in, you might need to spell out the word angle, but you can still use the plus symbol to abbreviate. Okay. So there's several ways that this will be used. It'll be used in calculations as well as proofs. So let's take a look at how it's used in calculations, starting from the simplest form. Okay. Simply speaking, the first one, if you look at the individual parts add up to the whole. So if you wanted to find what measure of angle XYZ is equal to, we simply take the sum of these interior parts. And you know that the whole is equal to 25 plus 32, which gives you an overall total of 57. So again, that's about as simple as it gets. Okay. You're probably not going to see a whole lot of this on any of the work other than just to illustrate the relationship that the sum of the parts is equal to the whole. And you're more likely going to see things like this example 3 and then this example down here. Okay, so let's kind of walk through this example 3. In here, let's just find angle X. We're only going to do the first part of this. Okay, so find X so that ray BE and ray AD are perpendicular to each other. So what do we know that the sum of those parts have to be? For it to be perpendicular, the parts have to add up to perpendicular means a right angle, so 90 degrees. And then it's just a matter of solving the resulting equation. So 3x and 6x add up to 9x. Divide by 9, you get your x value to be 10. Okay, now make sure when you're solving these types of problems that you're answering the question that's asked. Okay, so we did find x. Is that what we were looking to do? Yes. So we're done. This is our solution. And we can confirm our answer by plugging this back in and seeing what the angles actually measure to. So 3 times x is 30, 6 times x is 60. Do these add up to 90 degrees? Yeah, so it confirms that you have the right form. All right, so I want you to try this lower one on your own. Compare it to the answer that those sitting near you get. And just take about a minute and a half to answer that. All right, so let's take a look at how you can approach this. So often it's helpful for angle addition just as well as segment addition to sketch what you have. So we know that point Q is in the interior of angle POR. So if I set this up as POR, and the reason I drew it in this form is I was told down here that POR is 26 degrees. So I know it's going to be an acute angle, so I'm going to sketch it as an acute angle. Doesn't have to be sketched exactly to scale, but at least an acute angle gives a little help as far as setting it up. And it says Q is located somewhere in the interior. So if I set Q here in the interior, and then I express the angles that were given. Angle POQ was given by the expression x plus 4. Angle QOR given by the expression 2x minus 2. And so what I can now do is I can set up the sum of parts equals the whole relationship of angle addition and say that the parts x plus 4 and 2x minus 2 have to add up to the whole thing, 26. And then it just becomes a calculation. So I'm going to solve for x. Combining my like terms, I get 3x plus 2 equals 26. Subtract the 2 from both sides, I get 3x equals 24. And then the final step, divide by 3, I get x is equal to 8. Okay, now, just like I did up here, once you come up with your solution, make sure that you're answering the question that's being asked. Okay, I found what x was, but it asked me to find the measure of each angle. Okay, so what I need to do is plug this back in. So if I take 8 plus 4, that gives me 12. And then here, 2 times 8 is 16 minus 2. That gives me 14. And if I confirm this, do those add up to equal 26? Yes, it does. Okay, so I'm pretty confident that I have the correct answers for that. One of the nice things with angle addition and segment addition is you should be able to plug your values back in and confirm that you have the right answers.